The sales pitch for going to Mars is that it's going to be cramped, dangerous, difficult, very hard work. You might die, and that's the sales pitch. I hope you like it. So far from being some sort of escape hatch, it will be extremely difficult and dangerous and tough. Mars is a fixer-upper of a planet, and so it's going to take some work to make it easy to live there. But one day we could make Mars a planet like Earth, and I think we should. But the critical threshold, I think, for Mars is to have a city that is self-sustaining. It's going to be incredibly difficult to make a self-sustaining city because if it's missing any ingredient at all, however minor that ingredient is, then if the ships from Earth stop coming for any reason, the city will die out. Starship is capable of doing that. It's capable of getting 1 million tons to the surface of Mars and creating a self-sustaining city. And I think we should try to do that as soon as we can. The window of opportunity may be open for a long time, and I hope it is, but it may also be open for a short time. And this is the first point in the 4.5 billion year history of Earth that it has been possible. So and we're aiming for rapid reusability, which is why the booster is going to take off and then fly back to the launch tower and aspirationally land on the arms. If it does come in too fast and shear off the arms, then I guess it will be a farewell to arms. There'll be more ships than there are boosters because the booster actually, even though it's gigantic, will come back in about 6 minutes. The ship has to complete at least 1 orbit around Earth and sometimes maybe 3 orbits or more, and each orbit is 90 minutes. So the ship is probably, reusable about every 6 to 8 hours. That's why we say sort of 3 times a day for the ship. But in theory, the booster is capable of being reused every hour. So the propellant pumps are designed to fill the rocket in about half an hour. So this really is designed for rapid reusability. Just some facts about Starship, and these numbers will evolve over time. The height of the ship is about 50 meters, 164 feet. The 9 meter or 30 foot diameter. Well, you can just see it basically. It's got about 1,200 tons of propellant on the ship, and thrust is about 1,500 tons. Now these numbers will, we'll probably add more propellant over time, increase thrust. Diameter will stay the same. It's a huge pain to change diameter. So that'll tend to stay the same, but it'll probably get a little bit longer. And we're expecting payload capacity of 100 to 150 tons, depending on which orbit. So to a Starlink orbit, roughly 100 tons. Heat shield. So this is the world's largest heat shield, and this is we actually make this at our little factory in Florida near Cape Canaveral. We call it the bakery. And we're actually using a lot of techniques that are used for roofing tiles. So we need to have a heat shield that is capable of resisting extreme heat, but also is not crazy expensive. And our heat shield team has done amazing work in creating the world's largest heat shield, and one that is reusable, but also robust and low cost. So it's not a crazy money heat shield. That's one of the technologies that is necessary for getting to Mars. So the ship would get to orbit with its payload. Then in orbit, we'd refill the tanks, so it would have enough propellant to get to Mars. Mars is far. So let's see, the super heavy booster. So it was 70 meters, but then there was an extra half barrel section that the team deleted, and totally accidentally, it's 69 meters. It's also booster 4 and ship 20. I mean, this is a pure coincidence. Those numbers won't leave me alone. It's just, I hope it's good luck. So yeah, so so propellant capacity is like around 3,400 tons. I think like I said, it'll probably it will increase over time. Probably get to 36, maybe 3,800 tons. Thrust is around 7,600 tons. That'll probably increase too over time. Just to put this into perspective, though, the Saturn V was 7.5 million pounds of thrust, and Starship is 17. So it's more than twice the thrust of a Saturn V, which was that's the largest rocket ever to get to orbit. It's worth noting Super Heavy is the largest flying object of any kind, or will be. The next booster, we actually increased the engine count to 33. We've kind of bounced around on engine count. Because I think at one point we had like 37 engines, and then we went to 29. We finally settled on 33 engines, which is about actually the most number of engines you can actually fit under that booster without like expanding the diameter. This tower from design to construction was 13 months, so it's quite an epic structure. It's really worth emphasizing that the whole launch system, which is basically stage 0, is I'd say as complex and difficult as either the booster or the ship. So I really want to emphasize that this is and it's a very difficult thing that requires a lot of hardcore engineering, and it's really, like I said, the tower and the launch system, which I call stage 0, is just as important as stage 1 and stage 2. I mean, this is really some wild stuff here. In fact, I mean, hard to believe it's real, except, you know, it's right there. So, and then Raptor development. Raptor 1 was 185 tons of thrust. Raptor 2 is 230 tons of thrust, and I think over time we can get that to probably 250 tons. So that's, and it's also significantly simplified. So you can see the difference between V1 and V2. So it actually, Raptor 2 costs about half as much as Raptor 1, despite having much more thrust, and I think just generally being a much easier engine to build and a more robust engine. So very excited about Raptor version. So yeah, so Raptor 2 is pretty sick. We have some upcoming Starship missions. Orbital flight is really just the beginning. So we're going to have a number of Starlink missions that will launch Starlink satellite version 2. But even more exciting than that is the NASA human spaceflight mission. We're incredibly honored that NASA has selected Starship to take astronauts back to the moon for the first time in half a century, which is kind of mind-blowing. So, I'd just like to say, like, SpaceX is just deeply honored and appreciative that NASA would choose us for this incredibly important mission, and we'll get it done. And then there's also the Dear Moon mission, which is going to take artists around the moon, and that's Yusaku Miyazawa, and he's going to select I think a dozen artists and do a loop around the moon, which will be very exciting. And there's going to be some future announcements that I think people will be pretty fired up about. So anyway, super exciting future ahead with this. There'll probably be a few bumps in the road, you know, but we want to iron those out with satellite missions and test missions, and get to a high flight rate, and then have something that's extremely reliable for human spaceflight.